Hello. We are back for day 11, and today we are starting with the first day of building decentralized exchange. What are the components now that I want to build in these days? Uh, Today, that is day 11, I want to build a token pair, that is token A and token B. Okay. A faucet for these tokens, okay, so that people can claim this, can claim these tokens, write test for faucet and deploy scripts. I have made this repository, the folder where we have backend, frontend, and contracts. So we'll be doing all of those here. So let's go to contracts today. We'll write simple contracts for the tokens and token pair, and then we'll deploy those tokens to a faucet so that anyone can claim those tokens. As generally, what happens when token is created, that there is an airdrop which sends the token to a lot of people. Airdrop is done basically on based of different task, quest, proof of work, a lot of things, but we are keeping it simple. We'll build a faucet here. So let's do fortunate, and let's delete these three here and delete. src should have token dot sol, or I should say tokens dot sol. Yeah, that cool. And then we'll go for two tokens. We'll call them token A and token B. Yeah, that makes sense. So let's start here, and we'll start with SPDX license identifier MIT pragma solidity. Let's keep it 20. Now let's get the open zeppelin here. I have done this in all the files, so this is the main thing that we need to go for, because this has the implementation of ERC20. So you do not have to implement it from scratch. You can implement it using this class that they provide of open zeppelin as ERC20. Let's add the remappings here. Remappings. Yeah, that's cool. And this pragma solidity is done. Now we are making a token pair. So one contract will have token A, and the same contract will have token B. Now, what is a faucet? It's very simple to understand. So there are a lot of faucets here. Google Sepolia faucet. There is this faucet which gives you Sepolia tokens. So basically, if you want to get some Sepolia ETH, okay, you can go here and you go there and you get the ETH, right? That's your way to getting Sepolia ETH. So this is something that we'll build, that we may give them testnet tokens because everything will be deployed on testnet, and they can then interact with the pool and everything. Okay. Now what we want is someone to be an LP provider. Okay, so let's say we are minting 1 million tokens. Okay, 1 million tokens. We will not send all of them to a pool. Okay, so we'll keep the ratio to 50-50. Sorry, 50-05, not 50-05. The 50% of tokens will be sent to Faucet so that people can claim those tokens and interact, and 50% of them will be sent to the pool. So that pool has 500k A is equal to 500k B. That's our initial pool state. This pool will have a lot of complex stuff. We'll have balances, rebalancing the pool, all of it, a router specifically for this pool, and then the backend front end for this, right? So this is the approach that we are taking today. This will be a very short video as this is just a setup video and we'll get the pace as we go on. So we import this and then there is contract token where we can get it as token A is ERC20. Oh, directly we went here. Oh, that's not what we want. It's ERC20. There are interfaces also there in the contract. So constructor ERC20 will need a name token A and EKA, and now we'll mint these tokens, mint to message.sender. Here the message.sender is our main LP guy, right? So who has the tokens, who will feed the pool initially and he'll get those LP tokens in place of that. So 1E18, we'll keep 18 decimals for this guy, and I think this is the right thing. I mean, what's left to do? I don't think this will be 10 here. This will be directly multiplied to 118. Yeah, and this can be a constant. So public constant uh, max supply, and we can just go for max supply here. Okay, that's cool. And similarly, contract. There is some problem here defining the constant, so we can just take a quick look. Constant solidity. Let's go here. So not like, yeah, address public. Okay, so we'll have to go with event public constant max supply. Yeah, that's the syntax here. Token B is ERC20, and then the same thing that we did here, yeah, right now. So this guy and constructor, which will be the ERC20 constructor, token B, token B. Okay, that's cool. I think, yeah, that's enough for this. Now we'll push them to a person who will be the messenger sender. So messenger sender will have these two tokens in supply of 1 million, right? And let's do that using annual for now. We'll eventually deploy everything to Sepolia, or let's say base, because more base tokens here. Let's see where we can deploy everything. The base testnet, I have a lot more tokens. Yeah, that's on base. So we might deploy this on base. Does not matter if it does not work. We can get back to Sepolia anyway. Sepolia natively. So I hope the voice is clear in this video. Yeah, it is. Now let's get here and go for the .env file that we make every time. Can we RPC URL? Basically, we are writing tests for everything this time around. So we won't be missing anything here, and we'll be writing tests for each and everything, the faucet, the endpoints, everything. Right? And private key, this will be LP private key for now. Let's keep it LP private key. Okay. We'll not deploy everything unless and until it's made, because I want things to link up eventually. So yeah, this is done. And now let's make a faucet. Let's make a faucet.sol. Now what does this faucet have is it has these token A and token B in, let's say, 500,000 of each, and then it gives to people after certain block time. So block time, so there is something called block dot timestamp. Let me just show you here. Block dot timestamp, which gives you current block timestamp, that is seconds since last Unix epoch. So that is something we'll make sure that Faucet is rate limited here, and someone who has claimed tokens immediately cannot claim another bunch of those. So let's go for SPDX, license identifier MIT, pragma solidity 20, and then we'll go for, we need the interfaces now. I don't know what I've written here. I think this makes sense. And then we'll go for contract faucet. Faucet will be using this IERC20 interface, and then it will have IERC20 public token A and token B, and the max token that someone can get are 100. Is 100 a big amount? I think 10 should be good enough, 10 tokens of each. Now the constructor will pass address of underscore token A and token B, and we'll make the interfaces from them. Okay, now function request token A will give you, so we can make them as a separate faucets, or we can make those as one faucet. I'm not sure. Yeah, actually we don't need to send both of them. Users can see what token they want to swap and then get that token, right? So this is right. Let me just start the word wrap here. So this gives you message or sender and max tokens. Now let's make the error here to save guess. Error cannot, and let's revert this error here. That's done, and let's make an event here. Actually, we need this. Yeah, okay. And similarly, we'll have a request token B, which will also have these. And then we need a function to refuel the faucet, but let's keep it like this for now. We can refuel them by default. Okay, function get faucet balance, and it returns two events here. Okay, cool. And nah, okay, but cool. Now let's write tests for these, and then we'll try to get a little deployment on Anvil and see if it works as we test through token testing.p.soul. And let's start this contract. SPDX license identifier MIT pragma solidity 20, and then we have this here as purge, and we import the console. Now let's write contract test to, oh man, not this, token testing is test. Now for tests we need a function called setup here, setup here, setup, what is that? Yeah, setup. Okay, now deploy code. No, that's not what we want. We need a guy called address public lp provider, okay, is equal to address vm dot address 0. Okay, cool. Now vm dot start prank provider. Give it 100 ether. I don't mind, to be honest, but we want him or her to import deploy those tokens. So import token A, token B, and import faucet. Okay, Now token A is equal to new token A, token B is equal to new token B, and this would be good enough to be honest. So we have two tokens here. So now let's go for assert equal. Yeah, cool. That works. That works. Well, what's this one over here? Yeah. So on the setup function, we console log token address. Yeah, we'll console log. So setup. What we'll do in setup is we will mint these tokens to the LP provider. Okay, for now, and then we go for faucet creation and everything. Okay. So yeah, I mean that's cool enough to be honest. And now let's create the faucet. Okay, function test faucet uh, creation external. Okay, and vm dot start prank because nobody else has those tokens. LP provider uh, faucet faucet. Yeah, now no. Let's constructor, and then we will approve those tokens here. So approve faucet to spend tokens from LP provider. No, not this. I need to see how we write the approve script. So approve test boundary. How do we approve this guy? Token dot Let's first check the balance. Function test balance of LP external. Okay. Yeah, I mean without deploying. Actually, yeah. Address token B address. Okay, so we might need to do this, right? So let's take help from AI. Let's say improve the test so we don't have to redeploy tokens every time. That's something that we can rely on. So yeah, and we accept the file here, see what it is doing here. I see some red lines, but they went away. So there is token A and token B here. New token A, new token B. Let's test this now. For test, private key cannot be 0. Oh shoot. vm.address, what can we do? Ah, shoot. How do we get a mock address? How do we get a mock address? How to get mock address boundary test. vm.address. I want to see, yeah, exactly. vm.address. vm.addr1. This would work, right? vm.addr1 would work. Okay. Let's see if this works. Okay. Yeah, it's okay, right? Yeah, it ran. Okay. So these tokens are deployed. Let's console log these here. And let's read the logs basically. Token A address, token B address, we got it. Console log, okay, and similarly, so let's see if 1 million, yeah, they have 1 million of those tokens, right? Now let's test if the faucet is created, faucet creation external. Okay, so vm dot start prank with LP provider. Okay, so we give this faucet address. Okay, now we will say token a dot approve. Yeah, and we'll token b. Now we will token a dot transfer. Yeah, and not max supply by 2. Max supply by 2. Okay, so half of tokens will be there. Yeah. And let's get these console logs and we stop the plan. Test faucet creation. Let's see, I don't see it failing anyway. So yeah, 500,000 go in the faucet and the remaining 500,000 will go with the pool. And let's go back. I hope this video is not getting too long. Yeah, I mean it's just 20 minutes. Okay, so let's see requesting. Oh, actually, you know what faucet should also be here. Faucet public faucet. Faucet is equal to new faucet. That's cool. I hope this goes away. Yeah, it went away. It went away. Now function. Okay, test. Hmm. And you know what, we don't want this. We want an address public user is equal to vm dot address 2. Okay, and we'll just start the prank with uh user. Okay, and we'll go for user everywhere that we have used LP provider here, and here also user, here also user. Okay. Final balance inverse faucet dot max tokens. Final balance should not be this. Okay, vertical final balance should be greater than initial balance plus 1e 18 into 210. Yeah, that's what we wanted. Yeah, yeah, cool. Yeah, cool, 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 cool. Let's see this. Okay, let's test this. This fails. Why does this fail? EVM revert got the addresses. Why did this fail, man? Why did this fail? Let's see why did this fail. Okay, we are starting the prank with user and this should be 0. Let's see here. Token A balance before request is 0. So we are reaching here. Faucet dot request token B, is that a function? Request token and request token B is a function. Yeah. Yeah, I mean, okay, let's see the faucet balance. Okay. So the faucet does not have any fund. That's what my guess is. I think that's the problem there. So the faucet balance, if it is 0, it is 0. It is 0. Yeah, exactly. So we need to fund the faucet too. So I think we can make a function called fund faucet, which is also not an external, it is a public function. And in there we vm dot start prank LP provider, and we basically just transfer this stop prank, and here instead of this we call that function fund faucet. Okay, let's see if it works. Okay, I'm not sure if it will work. Let's see if it works. Okay. Yeah, I mean, I understand what's happening here. Let's vm.stop run. I'm just hard coding everything here. I'll explain what's happening. Yeah, it works. Ooh. Okay, so what was happening was initially when Faucet was created, it did not have any money to give to someone. So we need to get those tokens into the Faucet first, and that's why we created this fund Faucet function. Okay. Now here, before calling this, we'll call fund Faucet. Yeah, and then we call this guy. Okay, still it's failing. Still it's failing. Still it's failing. Let's see what's happening here. Uh, 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 uh. Actually, this should also go there. You know, this should also go there. Nah. So the wallet was being, faucet was being funded, right? Let's do something, okay? Let's not call this fund faucet. Okay, let's go here and let's start prank and let's give it LP provider. Yes. Then we need to actually create the faucet too, man. This is just faucet creation is uh, faucet creation, okay? And here that's whatever's happening here, want to do it here also, okay? Stop this and let's call faucet creation, okay? I'm not sure if this is going to work or not, but let's see whatever happens. We'll make through this. This works, okay? So we will call faucet creation here and let's see if this works. Request token pay. Yeah, now it goes away. So the guy has the tokens and same we call faucet creation here. Just have to do B here and A. Okay, so we have written tests for everything here. Okay, and is there something that is left? Let faucet balance. It's simple uh, function of function test get faucet balance. Okay, and let's see test get faucet balance. Yeah, it works. Oh my, yeah, cool. We have written tests. Now either we can write a script here, which I don't want to write since this there will be additions to this contract. Tomorrow we are going to understand something which is very important in a liquidity pool, that is called LP tokens. This LP tokens. So just a definition beforehand. LP tokens are cryptographic tokens representing a user's share in liquidity pool. So whenever you put some money in a pool or some token in the pool, you get a token back, which represents that you own some part of this pool. Okay. So that's what we are going to do today. I hope you had this in-depth session of writing test, writing to functions and creating a faucet, having fun in this one. And we'll build the DEX by what's the date? 2nd of May, hopefully, or 1st May, hopefully, yeah. So see you in the next one.